Yesterday, we looked at how we can solve a system by graphing and finding its point of intersection. Today, we're going to look at two algebraic ways to solve a system. Let's recall first, what does it mean to solve a system? The solution to a system is the ordered pair that satisfies both equations. In other words, the ordered pair that makes both sentences true. The solution to a system of two linear equations can also be thought of as the point of intersection. So if we're looking at the graph of a system, we're looking for its point of intersection. So there are two algebraic ways to solve a system. We use substitution to solve a system when it's easy to either solve for x or solve for y. In other words, isolate one of the variables. We can also use the addition property of equality to solve a system and eliminate a variable. We'll go through that. This method is called elimination. Okay, we're going to start with number one. It says to use substitution to solve this system. So I'm looking for a variable that's easy to solve for. So I see in the second equation that it's easy to solve for y. So I'm going to go ahead and subtract 2x from both sides. Y is equal to negative 2x plus 10. So I'm going to take the first equation and I'm going to do a little substitution. So I'm going to take out the y from that equation and I'm going to replace it with what y is equal to. That's called the substitution property of equality. If two things are equal, then we can substitute one for the other. So instead of a y, I replaced it with negative 2x plus 10. So now I have one variable in my equation, so now I can solve the equation. So I'm going to distribute first. Negative 8x plus 40. And I'm going to add my like terms. 3x plus negative 8x is negative 5x. And I'm going to subtract 40 from both sides. 12 minus 40 is negative 28. And then I'm going to divide both sides by negative 5. And so I can leave my x value as 28 over 5, or I can go to my calculator and I can do 28 over 5, and I can write it as 5.6 if I want to. So I'm going to say or 5.6. So what I'm going to do now is, now that I've solved for x, remember the solution to a system is an ordered pair, not just an x value or a y value, but an x comma y. So I need to take that 5.6 and plug it back in to the equation, one of the equations, because I know that it will make the sentence true. So y is equal to negative 2 times 5.6 plus 10. So y is equal to, let's go to our calculator, negative 2 times 5.6 is negative 11.2. Negative 11.2 plus 10 is negative 1.2. So my x is 5.6 and my y coordinate is negative 1.2. There we go. All right, let's go to the next one. We're going to do substitution again. I'm going to look for a variable that's easy to solve for, and I see in the first equation it's going to be easy to solve for x. So I'm going to subtract 3y from both sides. So I get x is equal to 5 minus 3y. So I'm going to go to the second equation, and I'm going to take out the x, and I'm going to replace it with 5 minus 3y. So I have negative 2 times 5 minus 3y. So it was negative 2x. Now it's negative 2 times 5 minus 3y. Minus 4y is equal to negative 5. So I took the equation that I didn't solve for, and that's the equation I use, and I substitute into that equation. So I need to distribute now. So negative 10 plus 6y. Remember, watch your signs. A negative times a negative is a positive. So we're going to add our like terms now. 6y minus 4y is 2y. Add 10. 2y is equal to 5. So y is equal to 5 over 2. All right, so now I know that x is equal to 5 minus 3y. So I'm going to rewrite that equation. X is equal to 5 minus 3 times 5 over 2. X is equal to 5 minus 15 over 2. So I'm going to go to my calculator now. 5 minus 15 over 2. If I write it like this, remember it gives me my fraction answer. Negative 5 over 2. So does everybody see what I did? 5 minus, and then if I put my fraction in as a fraction rather than in parentheses with the division sign, the calculator will give me a fraction answer. Negative 5 over 2. So my solution to this system would be negative 5 over 2, comma 5 over 2. We could write it as an ordered pair. Make sure we write our solutions as ordered pairs, because that's what they are. Okay, so that's the first method. The first method is substitution. So notice we took one of the equations, we solved for either x or y. Does it matter which one I solve for? No, it does not matter. So you're going to look for the variable that's easiest to solve for. You want to do the least amount of work that you need to. And then you go from there. Okay, so now let's talk about elimination. Elimination is when we add the two equations together, and when we do that, we eliminate one of our variables. So I notice in number 3 that if I were to add these two equations together right now, I would eliminate the x's because I know that 4x plus negative 4x is 0. So I'm going to add these two equations together. Net 4x plus negative 4x is 0. 2y plus 3y is 5y. Bring down your equal sign. So what you're going to do is you're going to add the left side of the equations together and then add the right side of the equations together. 9 plus 16 is 25. So then I end up with a simple little easy equation that only has one variable, so I'm going to solve for y. So y is equal to 5. Okay, so now that I know that y is 5, remember my solution is an ordered pair, so I am not finished yet. I have to plug 5 back in for y into one of the original equations and solve for x. So I'm going to rewrite 4x plus 2 times y is equal to 9. And instead of a y, I replace it with 5. So 4x plus 10 is equal to 9. Subtract 10 from both sides. 9 minus 10 is negative 1. And we're going to divide both sides by 4, and we get negative 1/4. Okay, so I get my x coordinate and my y coordinate, so I'm going to write negative 1/4, comma 5. Okay, so the whole idea is that we add the equations together, and while I add the equations together, one of my variables eliminates. So we have to think about why did the x's eliminate in this example? Well, the x's eliminated because I had my coefficients 4 and negative 4, that when I added those together, I got 0. So that's what I'm looking for. I'm looking to add the two equations together and get 0 when I combine the coefficients. So I'm going to look at number 4. Number 4 looks a little tricky because if I add the equations together right now, 2x plus 3x is not 0, and 7y plus 5y is also not 0. So when we get this situation, what we have to do is, I'm going to write a little note, we have to multiply. We have to multiply something to either one of the equations or both, and it doesn't have to be, if you decide to multiply something to both of the equations, it does not have to be the same number. So in order to eliminate one of my variables, I think what I'm going to do is I'm going to multiply this first equation by 3. So that gives me 6x plus 21y is equal to 12. So I just multiplied the whole equation by 3. And I'm also going to multiply the second equation by negative 2. So if I multiply the second equation by negative 2, I get negative 6x minus 10y is equal to 10. Notice when I do this, I multiply the first equation by 3, second equation by negative 2. Notice when I do this now, if I add the equations together, the x's are going to eliminate. I could have decided to eliminate the y's if I wanted to, but I just decided on the x's. So 21y minus 10y would be 11y equals, and then I'm going to add the two other side together. 12 plus 10 is 22. So if I divide both sides by 11, I see that y is equal to 2. So now I'm going to take one of the original equations, 2x plus 7 times y is equal to 4, and plug in 2 for y so that I can solve for x. Okay, so I'm going to subtract 14 from both sides. I get 2x is equal to negative 10, so we get negative 5. So my ordered pair is negative 5, comma 2. Okay, so sometimes we don't have to multiply, but most of the times we probably will. So what we're looking for is let's highlight it. We're looking for this situation right here when we have a 4x and a negative 4x, or 6x and a negative 6x, so that when I add the two equations together, my variables will go away. Okay, so let's practice that a little bit more. Let's look at number 5. It says decide which method is best. Okay, so we can decide, let's see. If I take the first equation and I add x to both sides, I'm solving for y, aren't I? So I get y is equal to x minus 2. So I'm going to go to the second equation and I'm going to rewrite it, but I'm going to take out the y, and instead of a y, I'm going to replace it with x minus 2. Notice I'm doing substitution here because I saw that it was pretty easy to solve for y. So I'm going to distribute now. So I get 2x minus 2x plus 4 is equal to 0. So when I add my like terms, look what happens. 2x minus 2x is 0. So I end up with 4 is equal to 0. So we know what happens when we try to solve an equation and our variables go away. We end up with either a true sentence or we end up with a false sentence. And so since this sentence is false, we're going to say there is no solution to this system. And if we did get a true sentence, then that would mean that there would be infinitely many solutions. So remember, so when we're looking at lines, they either intersect once, they intersect no times, or they intersect infinitely many times. So if they intersect no times, then we'll see this situation here. But if we get a true sentence, then that would mean that they intersect infinitely many times. Okay, let's look at the next one. So the next one, I think what I'm going to do is I'm going to do some elimination. So I'm going to multiply the first equation by negative 1. So when I do that, notice I get an equation where when I add the two equations together now, the variables go away. So 2y minus y is 1y, and 30 plus 0 is 30. So y is equal to 30. And I know that 5x plus 30 is equal to 0. So 5x is equal to negative 30. So we get negative 6. So negative 6 comma 30. So elimination here was definitely the best method. It was definitely quicker in this case. Okay, so we're going to look at a couple of applications now. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? So we have two unknowns here. So we'll call C the cost of each lesson, cost of a lesson, and we'll call F the one-time fee for the materials. And we see that if you take 6 lessons, then your price is $300. And if you take 12 lessons, it's only $480. So it says the prices include the one-time fee. So let's come up with some equations that we can use to figure this out. So we've got that 6 lessons times the cost of each lesson plus the one-time fee is going to be $300. So 6 lessons for $300. 6 times the cost of each lesson plus the fee, the one-time fee, would be $300. And 12 times the cost of each lesson plus the one-time fee would be $480. So what I have here is a system. So I need to decide if I want to do substitution or if I want to do elimination to solve this system. I think I'm going to do elimination because I see an F and an F. So if I multiply the first equation by negative 1, then I'll have a negative F and an F, and that will work in order to eliminate. So I'm going to multiply the first equation by negative 1. So I get negative 6c minus F is equal to negative 300, just like I did last time. So now I'm going to add the two equations together. And I see F plus negative F is going to go away. That's 0. So I'm going to add the left side together. 12c plus negative 6c is 6c. And 480 minus 300 is 180. And if I divide both sides by 6, I get that c is equal to 30. So that means the cost of each lesson is $30. And so we're going to plug 30 back into one of the equations. 6 times 30 plus F is equal to 300. And figure out what the one-time fee is. 6 times 30 is 180. And we're going to subtract 180 from both sides. And we're going to get, let's check our calculator just to make sure. 300 minus 180 is 120. So $120. So let's see, $30 for the cost of each lesson and $120 for the one-time fee. So that wasn't too bad. Let's see if we can do that one more time. A cafe sells a regular cup of coffee for $1 and a large cup of coffee for $1.50. Melissa and her friends buy 5 cups of coffee and they spend a total of $6. How many large cups of coffee did they buy? How many large cups? Okay, so we've got 2 different unknowns here. How many large cups did they buy and how many regular cups? So we're going to call R the number of regular cups of coffee and L for the number of large cups of coffee. So we've got $1 times the regular cup, number of regular cups, plus $1.50 times the number of large cups is equal to $6. So $1 for every regular cup, $1.50 for every large cup is $6 total. And they bought 5 cups of coffee, so that means the number of regular cups plus the number of large cups is equal to 5. So here's my system. One more time, I have to decide if I want to do substitution or if I want to do elimination. I think I'm going to do elimination here. So I'm going to rewrite the first equation, r plus 1.5L equals 6. And I'm going to multiply the second equation by -1. So negative r minus L is equal to -5. So I can eliminate my r's now and add the other like terms together. 1.5L minus 1L would be 0.5L, and 6 minus 5 is 1. So we're going to divide both sides by 0.5. And so L is equal to, let's check our calculator, 1 divided by 0.5 is 2. So we've got 2 large cups of coffee. 2 large cups of coffee. And did I answer the question? How many large cups did they buy? The answer is yes, I did answer it. So there it is, 2 large cups.